So again, we're going to go backwards. We're going to do the graph of a tangent function. The reason we haven't done that so far is because a tangent function is going to have places where it is undefined. And we're going to do, again, a couple identities and then just a little bit of review. All right, so I want you to move back to your previous lesson. So this would have been lesson 12, question number 5. All right, so if you can take a moment and please find this one. Oh, right there. So we are going to graph y is equal to the tangent of x on the axis below. So I'm going to make you change your window because that's what most people need practice on. So we are going to do this window just for your pi, and we're going to go from just 0 to 2 pi only. So this one, I want to graph it from 0 to 2 pi only. So just a small little section. And tangent is periodic as well, so it's still going to repeat that same pattern. So just like we did yesterday, pi is approximately 3. So I start at 0 and I count 1, 2, 3. And you guys remember the first mark here? 90 degrees, which is in radians, pi over 2. 1, 2, 3 pi, that's 180. 2 more. 1, 2, 3, 3 pi over 2. And lastly, 1, 2, 3 boxes, 2 pi. You will not have to scale your own graph on your quiz. Okay? Most of your graphs are already set up. You're just interpreting, all your different vocabulary. So now what we're looking for is essentially the amplitude to figure out how to scale the y-axis. This tangent graph, again, this is much different than sine and cos. You'll see why in a second. I only have to technically hit up to 1 and -1. So I'm going to do this. So I'm going to skip and go 1, skip and go 2. And then I'm going to skip and go -1 and then skip and go -2. Okay, we're going to change the window on the calculator. I want you to label this right on your paper to see if that helps. The first thing the calculator is going to ask you for is the x-min. So to find an x-min, no matter what type of graph you're given, you go on the x-axis and you find the smallest thing you labeled, which was 0. So this value on the left is always your x-min. Now go on your x-axis all the way over to the other side, and what's the biggest x we labeled? 2 pi. Good. So that comes right from there. You just read it right off the graph you're given. Okay. The next thing you're looking for is the scale. The scale is always the first value that's labeled to the right of 0. So in this case, the scale is going to be pi over 2. I'm going to put that over here just because I'm going to need that space. So the x scale is always to the right of 0. So this goes to the right of 0. The first mark you see, pi over 2. Next is going to ask you for the y-min. So to do the y-min, I go on the y-axis, and what is the smallest value we labeled? -2. And what is the largest value that we labeled? 2. Yeah. And the last thing the calculator is going to ask you is, what did you scale this by? And again, you have flexibility in this. You don't have to always do it the same as mine. So what did I scale it by? I went by 1/2. I'm going to put that over here just in case you want it written. So y scale, we went by 0.5. Okay. Everyone see where those come from? So that's always set up like that, no matter what type of graph you have. You always go across it, figure out what you got, and then up and down. Okay, so let's take this. The reason tangent is different is if you remember back to your unit circle, tangent has 2 locations for which it's undefined. So I'm going to go window. I'm going to go 0. And I'm going to go 2 pi. And my scale is going to be pi divided by 2. So scale is pi divided by 2. Y min is -2, Y max is 2, scale is 0.5 still, don't change anything else. And then immediately I'm gonna hit mode and confirm that I'm in radians. So I'm good. Y equals tan X. Again, this is going to look significantly different than your sine and cosine graphs because your tangent function has places which is undefined. So right there where you see this first mark, this is 90 degrees and this has what we call a vertical asymptote because your tangent graph can't approach that or cross it. Same thing back this way, tangent's undefined at 3 pi over 2, so we're going to draw in just an asymptote. So here's what you're actually going to graph here. And again, you don't need a ton of these values. So I'm going to graph 0, and then I'm going to approach the asymptote. This one I'm going to graph 0, and then about halfway -1, halfway +1, and then this one's just the 0. So let me show you. All right, so back to your graph. What we're going to do is put the asymptotes in first. So grab a color pencil, and at pi over 2, you are going to draw in your asymptote, which is again a line that tangent will approach but never cross. Sine and cosine obviously did not have these. And then this way. Okay. So again, these are what we refer to as asymptotes, and they are the location for which tangent is undefined. Now I'm going to switch colors. And I'm going to sketch this. So tangent graph starts at 0. And then it's going to approach your asymptote and continue. I'm going to do something very similar in this next part. So I had this point located at 0. It went up, approached your asymptote, and back through. Arrows. All right. And then lastly, I'm going to grab this value that was at 0. And then it goes right down like so. And that's it. That's your tangent graph. So significantly different. Okay. Any difficulties doing that, guys? Okay. So now we're going to do a teeny bit with your identities work, just a teeny bit, and then move into just reviewing everything. So I'm going to advance to lesson 13. And we're just going to refresh on some of these rules and do a couple of what we call identities. We got at this yesterday. You can take a sine graph and translate it and obtain a cosine graph. Okay. You will work with these a lot more when you take math analysis or pre-calculus next year. And identities are just nice ways that you can replace different trig expressions into equations to solve. So this top part is just a basic review of all your different transformations. So when we have a negative in front of our equation, we do this a lot for cosine. When you place the negative in the front, that was a reflection over x-axis. So that was a reflection over your x-axis. Letter D, we didn't actually do, but maybe you remember it from the past. If you have a negative inside, instead of reflecting over the x, what do you think that one does? Close. This just reflects over the y. Good guess, though. Reflection over the y-axis instead, because of that negative. Letter B and letter E, those are your phase shifts from yesterday. So when we had plus, we were always remembering that this does the opposite. So plus is actually going to be a phase shift to the left. So phase shift left. And over here, this one is your phase shift to the right. So phase shift to the right, and that is always located inside your parentheses. Okay, and then letter C. This is when you had the midline, and this was your vertical shift. So this would be, again, a vertical shift up A units, where A is your midline. So this is a vertical shift up. And again, if you have minus, this would be a vertical shift down. So vertical shift down. Again, we call that value a midline value. Okay. So all we're looking to do here is take the existing graph and apply a transformation to it. And what you're going to see with some of these, because again, we're not going to do all of them, is that sometimes you can take a sine curve and translate it and obtain the identical picture that's on your graph. And those are what we call trig identities. So it just means it creates the identical image. So letter N. We want to graph sine of x plus pi over the interval from -2 pi to 2 pi. So I'm going to make you practice changing your calculator. What's on here currently is just a normal sine curve, y equals sine of x. So label that one, please. That's what's existing. And now I want to make you change your calculator. So to be able to type this in, what is my x min going to be? You guys see it? X min is -2 pi now. Okay. What is going to be my x max? 2 pi. Good. So you read it right from the graph, whatever it happens to be. So left, right. Now I need to find my scale. So what I do for my scale is I go to 0 and I look at what's next to it. What's next to it? I know it's kind of hard to see. Pi over 2. So x scale in this case is pi over 2. Yes, that can change, but those were the same as before. Next, I need my y min. So you're going to count this. So this went 1, 2. So this goes -1 and -2. This is my y min. My y max is going to be 2. And my scale, I believe, is the same we just put in the calculator, 0.5. The y scale is 0.5. Everyone getting comfortable with that? Okay. Again, that is one of the most important things that we discussed. Go to your calculator now and type this in. So I'm going to go right to my window. My x min is now -2 pi. My x max is 2 pi, which is what we had before. And actually nothing else has to change, does it? Nope, we're good. So you're going to go y equals, and you're going to type in what is here. So we are going to go sine of x plus pi, which represents a phase shift. So your sine graph should be moving pi units to the left. So you're going to hit graph. Okay, so it looks just like this. So you're going to sketch that picture right on your graph. So we're going to go 0, -1, 0, 1, 0. And I'm going to ask you if that is an identity or if that is different than the existing picture. All right, so back over. I'm sorry, I'm having computer issues like constantly this week. Sorry, one moment. Go ahead and copy your graph, please. Okay, hopefully that works. 0, -1, 0, 1, 0. So is this the same identical graph or is it different? This one's different. So this is not a trig identity. So sometimes your questions in the future would ask you, are these identities? You would just say, no, does not produce a congruent image. So these are not identities. We're just going to do 2 more of them. Now you're going to graph the next one. You do not have to change your window at all. So there's a negative in the front. So if you want, you can put it in the calculator, or you can do it by hand if you remember your rules. What does a negative in the front do? Just like we did with those cosine graphs. reflected, exactly. So this reflects over the x-axis. So again, if you want to, you can take the existing graph and just flip it, or you can go to your calculator, both are fine. If I take these points and flip them, this one would go below. That one would be on it. This one would be above it, on it. So these are also not identities. However, this graph you're drawing right here is equal to the one we drew above. So those represent identities. Okay. So again, these are not identities. They are different. However, if you compare the two you just did, those were the same. My orange and purple are exactly the same. So I could say that the sign of x plus pi is equal to negative sine of x. It's not anything you have to memorize. Okay. I'm going to do one last one here. So this graph, I have sine of negative x. This is a reflection over the y-axis. Again, if you want to do it by hand, you can, or you type it in the calculator. So I'm going to type this in quick, and I'm going to go sine of negative x. And I'm going to delete the rest of this and make one more graph with that. Okay, so it looks just like this. So it's going to go 0, negative 1, 0, 1. So 0, negative 1. 0, negative 1, 0, 1, 0, which if you notice is exactly the same as the one above it. And right back around. So it's going to go below it, on it, above it, and back down. Okay. So again, that one would be equivalent to the one above as well. Okay. You understand the concept of identities, just being able to produce an equal image? Okay. So that is all we're going to do with those. So the last item was placed on your desk when you came in, and that is just a nice overview of the important concepts that you want to be comfortable with for your quiz moving forward. So you're going to find this sheet right here that was on your desk. Okay. So I wanted to consolidate all your information into one place so that you had one document to look at. Okay. So above for your boxes, I'm going to just write out an example in general form here. I'll use sine. So I'm going to say y is equal to a sine, we'll go bx plus c. And I want you to just first tell me what all of those letters stand for. So the first is the A. And what does the A stand for? Amplitude, good. And it's worth mentioning, the amplitude is never what? Good. So never negative. Again, if you have a negative, it denotes a reflection over the x-axis instead. The letter B stands for what? Frequency, good. You want to know that. So frequency. And the letter C represents your midline, yep, which is a vertical shift up or down, again, if you have one. The next formulas that we did, doesn't matter the order you write these in, is we did the formula for period. And what was the formula you had to know for period? Yep, 2 pi over b, in which b is your frequency. So you can write it as b, or you can write out the word frequency if you'd like. The next thing that we did is we found your amplitude. And your amplitude was equal to your maximum minus your minimum divided by 2. These are your notes, abbreviate whatever you'd like. And then I immediately told you to do the midline next because, I don't know, I think it's kind of easiest. Next, we did the midline. And your midline was equivalent to your maximum plus your minimum divided by 2. There's only 2 more that you had to know here. Okay. How's that so far? Pretty good? Okay, so your last 2. We asked you to find a maximum. And when you were told to find a maximum, all you did was midline plus amplitude. And the last thing that you were told to find was a minimum. And a minimum is very similar. But what do I change? Yep, subtract. So this is going to be your midline minus your amplitude. Okay. And then here's just a couple little questions that go with those. So I think I'm going to go through them with you just because, again, I want you to feel comfortable with these. So number 1 asks you which sinusoid has the greatest amplitude. So you have a multiple choice question. You have this choice, equation, equation. Let's start with the equations. They're probably the easiest. So amplitude for this one right here, my amplitude is just 3. Yep. Over here, my amplitude, don't get tricked, is what? 5. It is not negative. That's your reflection. Now, the other 2, to do my amplitude, you can either eyeball it and kind of split it and count up, or you can use the little formulas that you just wrote. A lot of you guys like formulas, so that's fine. I'm going to do max minus min divided by 2. So max min divided by 2. So I'm going to go 7 minus 3 divided by 2, which is 4 divided by 2, which is 2. Over to the next one. I'm going to do maximum, which is at 3. I know this is a little bit tough to see. And then minimum is at -5. And again, divided by 2. So maximum minus minimum divided by 2. So this is going to give me 8 divided by 2, which is 4. Okay, so the amplitude you are comparing here are 2, 4, 3, and 5. Which one has the greatest? That choice. The choice B. Next, give you a picture. State for me the amplitude, the midline, the max, and the min. So I'm just making you practice your formulas. Amplitude, we just did it a second ago. So I'm going to do max minus min divided by 2. So amplitude equals max minus min divided by 2. So I'm going to go 6 minus 2 over 2, which is 4 over 2, which is 2. Next, I'm going to find the midline. So C is equal to max plus min divided by 2. And that is going to be 6 plus 2 divided by 2, which is 8 divided by 2, which is 4. So it should look like right now, if I take this at 4, it should look like it splits it evenly. Okay. So again, if you've got a good eye, you could do that too. And if you wanted to find your amplitude, the amplitude is always this distance right here. Okay, so if you're not a formula person and you're more visual, you can do it like that. What else do we need? The maximum and the minimum. So the maximum was located at 6. And the minimum was at 2. So no work involved on those. You're just pulling them off your picture. How do you guys feel with that one? Pretty good? So last couple here. So number 3, what is the minimum value? So what is the formula to find a minimum? Yep, she's right. So minimum equals midline minus amplitude. This is just going to be algebraic. So I am going to take here the C, which is my midline, minus the amplitude, which is just 2. And there's nothing more I can do with that, so done. So my minimum is represented as just C minus 2. Okay. And then lastly on the bottom, the path traveled by a roller coaster is modeled by this equation. What is the minimum altitude of the roller coaster and the period? So I want you to find both. So minimum is again going to be midline minus amplitude. So my minimum is equal to midline minus amplitude. So I'm going to go 30 minus 27, which means my minimum is 3. And then I asked you for the period. All right, what's our formula for period? Yep, 2 pi over b. So period equals 2 pi over b. So period is equal to 2 pi over the 13. And there's nothing more you can do with that. So again, this is the b value right here. All right, if you are confident with those and you are confident changing your window around with your calculator, then you are in excellent shape for your quiz tomorrow. Do you guys have questions or do you feel better on those? We feel good? Okay. You don't have any formal homework other than to please study those 5 formulas. Okay.